This is another CSIR problem of Linear Algebra 2023, and the problem says that let A be a 3 cross 3 real matrix such that x squared divides the characteristic polynomial of A. Which of the following statements are true? We are interested which of the following statements are true. The eigenspace of A for eigenvalue 0 is of dimension 2. All the eigenvalues of A are real. A cube is equal to 0 and A is a diagonalizable matrix. Okay, first of all, look at that. X squared divides the characteristic polynomial of A. I should write it as CH. Characteristic polynomial of A. Okay, x squared divides. This what does mean? This shows that implies 0, 0 are two eigenvalues of A. Okay, we are sure that there are two eigenvalues of A, 0, 0, and this is a 3 cross 3 matrix. So third eigenvalue must be real. So all eigenvalues are real because complex comes in pairs. Complex eigenvalues comes in pairs. So all eigenvalues are real. This option is correct. And when we move to first, let's see. Okay, now see the first part. It says that the eigenspace of A for the eigenvalue 0 is of dimension 2. In simple words, this first part is saying that nullity of A is 2. This is not true. We can give an example. This is a very simple, famous example of a nilpotent matrix. Say 0, 0, and we take it 1, 1 here, 0. Okay, this is a matrix such that A cube is equal to 0. Okay, so characteristic polynomials x square divides the characteristic polynomial. Its characteristic polynomial characteristic of A is x cube is equal to 0. X cube is its characteristic polynomial is x cube. Okay, so we have A cube is equal to 0. This is an example, and its nullity is 1. So first is not true. Third may or may not be true because we have an example, but it is not always possible that every matrix look like this. We can give a very easy example. Only we need is that characteristic polynomial x square is a root, the x squared divides the characteristic polynomial. So we can have characteristic polynomial like this, x square into x minus 1. We can have any characteristic polynomial, and for this A cube is not equal to 0. A, for this A cube is, if you want the matrix, I can construct a matrix for this. Alright, we can construct a matrix too, but if you can easily see that this polynomial, its characteristic polynomial is x square. X square. Also, we know that from the that theorem, famous Cayley-Hamilton theorem, that every polynomial satisfies characteristic polynomial. So in this case, if characteristic polynomial is this, in this case the matrix will satisfy A square A minus I is equal to 0, and not this. So this is also false. We can find a matrix like this which satisfy this, say, and which satisfy this condition, uh, a square into a minus I is equal to 0, and it satisfies all the condition of the question, and it is not like this. Okay, this is not true. Okay, now is the last part, and for the last part again the same matrix A0 0 0, this nilpotent matrix. We know that nilpotent matrix is diagnosable if and only if A is equal to 0, but this is not. This is A cube is equal to 0, A is not equal to 0, and it is not diagnosable. It is not diagnosable and it satisfies all the properties of the whatever the question is asked. So this is also wrong. Only correct statement is second part. This is only the correct statement.